Hello friends, welcome to the Academia Diego channel, the channel where we always try to explain mathematics in an easy and simple way. This video is translated into English with the help of artificial intelligence. I hope it is helpful to you for your studies. Truly, that would be my greatest dream and what would make me very happy. If so, leave me some comments as it is always good for me to learn from you. We start after the intro. Before starting the exercises, I want to tell you about a series of elements that all right triangles have. When we have a right triangle, this would be its acute angle. Looking from this alpha angle, obviously this leg here would be the opposite leg. This green one here would be the adjacent leg, also called adjacent leg. And that if we look at it from this acute angle, well, if we look at it from just the other acute angle, it would obviously be the other way around. All this would be the opposite side. I have also marked it in red. All this would be. We have also made the adjacent leg green, and in both cases what is right in front of the 90-degree angle of the right angle, as it is the hypotenuse, which is the longest side. Well, that doesn't matter to me anymore. No matter where you look at it, the hypotenuse is always the longest side of a right triangle. Taking that into account, since the formulas of trigonometry, remember that there are three formulas. One is sine, which is the relationship between the opposite leg and the hypotenuse. Another is that of the cosine, which is the relationship between the adjacent leg and the hypotenuse. When I say the relationship, it is the division obviously, and finally the tangent, which is the division or quotient between the opposite leg and the adjacent leg. On the other hand, alpha and beta, which are the two acute angles of a right triangle, always add up to 90 degrees, since the other is a right angle also of 90. Well, taking all that into account, we can now start doing the exercises. And we are going to start with the three theoretical ones, as you have seen in those of these three triangles, because it gives us a series of clues and asks us to calculate the other elements, both sides and angles. So this is where you are going to really learn, to know when to use the sine formula, when to use the cosine formula, and when to use the tangent formula. Let's start with the first of the exercises. That of this right triangle, because it gives us a clue that this leg measures 10. We do not know the hypotenuse and the opposite leg. We also know that this angle has an amplitude of 35 degrees, and we do not know the amplitude of the other acute angle, which is beta. Well, to solve this type of exercises, I wanted to tell you one very important thing that you have to take note of, and that is that to know when to use sine, cosine, and tangent. The important thing, the key is to know how to answer these two questions: what do we know about the triangle, and what we want to know about the triangle. What do we know? Well, in this case we know the amplitude of angle alpha, and from that angle alpha the length of its adjacent or adjacent leg. That's what gives us the problem. What do we want to know? Look, well, without going any further, we want to know the opposite side of the formulas that I am going to put here again, the three formulas sine, cosine, and tangent. Let's think about which of the three is the one to use. Well, one that relates precisely these two elements, what we know and what we want to know. What relates adjacent leg to opposite leg is the tangent formula. That is the formula to use here. So tangent of a tangent angle, in this case 35 degrees, which is the angle that we know is equal to the opposite leg, which we do not have what it measures, but divided by 10, which is the length of the adjacent leg, which we do know is that distance because the problem gives it to us. This 10 is here dividing. It would happen by multiplying and doing the operation. As with the calculator, we know that tangent 35 is 0.71 times 0. It tells us that the opposite leg of this 35-degree angle in this triangle measures 7 centimeters. Well, once we know that this is the length of the opposite leg, we are going to continue to solve the problem by asking ourselves the same questions as before. What do we know? What do we want to know? Well, it is clear that now what we know is everything we knew before. The length, the amplitude of the alpha angle, 35 degrees, the length of the adjacent leg, which was 10, and the longitude as well. Now we also know that the opposite leg is 7 centimeters. All this is what we know we want to find out, because without going any further, we still need to find out the length of the hypotenuse. So what relates the adjacent leg to the hypotenuse of the three formulas is the cosine. And that is the formula that must be used because it is the one that contains both what we know and what we want to know. the cosine of 35 equal to the adjacent leg that measured 10 times the hypotenuse, which is what we don't know, and then solving this hypotenuse as it is dividing would happen by multiplying, which will leave us with the hypotenuse times the cosine of 35 equal to 10. Solving the hypotenuse, there would be 10 divided by the value of the cosine of 35, which with the calculator rounded to the nearest hundredth comes out to 0.8210. Between approximately 0, it gives us 12 and that is the length of the hypotenuse that we did not know. The last thing we need to find out is the amplitude of the beta angle, and since we know that alpha and beta add up to 90 degrees because we have said it before, since the other was also 90, eliminating beta from here would leave beta 90 minus alpha, or so, which is the same, beta will be equal to 90 minus 35, or what is the same beta would be worth 55 degrees. We place it and we have it. Now this exercise is solved. Let's go with the next one. The second of the 3 theoretical exercises in this tutorial tells us the following. We place the 3 formulas and now the triangle from which we want to find out a series of unknown elements. We are clear that the length of the hypotenuse measures 15. The amplitude of this acute angle is 48 degrees and we do not know everything else. The length of the 2 legs opposite and adjacent to 48, as well as the amplitude of the alpha angle. Well, looking from beta, in this case, since we are working with the one we know as this one, we are going to think a little about the 2 questions that need to be asked. As always, they are the same ones that we know and that we want to know, since we know the length of the hypotenuse 15 centimeters and the amplitude of the beta angle. That's what we have at the moment. Good. What do we want to find out? Well, look, without going any further, at the length of the opposite leg that relates the opposite leg to the hypotenuse of these 3 formulas. The sine function, so that's the one we're going to use. We would say sine, in this case beta, which measures 48 degrees equal to the opposite leg, which is the one we do not know divided by the hypotenuse which was 15. This 15 that you are dividing would multiply by the sine of 48. Leaving the opposite leg equal to 15 times 0.74. Rounding in this case the hundredths, and doing this operation gives us opposite leg equal to 11.1. 11 centimeter. That's what this guy measures. Well, we return now to finish the problem by asking ourselves the necessary questions so that we know what we want to know. Well, we know everything about the hypotenuse and beta angle before, and we also already know the opposite leg. So what do we want to find out? Well, we want to find out the length of the adjacent leg. And what of the 3 formulas relates the adjacent leg to the hypotenuse? Well, the cosine. Then we would say cosine, in this case beta of 48 degrees equal to adjacent leg divided by 15, which is the length of the hypotenuse. This 15 that is dividing happens by multiplying and doing. The operation gives us that the adjacent leg measures 10.05. We put it here in its place. We already have it. And finally, to finish solving this problem, we only need to find out the amplitude of the alpha angle, since we know that between alpha and beta they add up to 90, and solving for alpha, which is what we do not know, there would be 90 less beta, and as beta it is worth 48 degrees, while alpha would be 90 minus 48, or what is the same as 42 degrees. We put it there in its place and we have it. Has the second exercise of the theorists been made clear? Well, let's go for the third and last one. It's very interesting because it has nothing to do with these. The third of the theoretical exercises in this tutorial to find out when to use sine, cosine and tangent. We place the formulas first, and then here the triangle gives us a clue the following. This leg measures 21. This hypotenuse measures 30. We do not know both alpha and beta, and we also do not know its opposite side of alpha. Assuming that we are looking from alpha, then if we look from alpha, 21 represents the contiguous or adjacent leg and 30 logically represents the hypotenuse. That's what we know and what we want to find out. Obviously it will be the alpha angle. The first thing, because it is the most important thing, is the key to being able to finish solving the problem. So I insist, we know the adjacent leg and hypotenuse looking from alpha. I insist, and we want to know for the moment that amplitude of the alpha angle. Therefore, what relates the adjacent leg and hypotenuse of an angle? Well, obviously it is the cosine. That cosine formula is the first one we put here, and we would say cosine of alpha, which is the unknown angle equal to 21, which is adjacent leg between 30, which is hypotenuse, 21 between 30 is 0.7. And so now here I want to explain something important to you. That's why this exercise, was different from the previous ones. Since I don't know the amplitude of alpha and I want to find out, I have to do the reverse process with the calculator in the following way. We have the calculator and we write 0.7, which is the value of this cosine, and the sequence of keys that we give is the following shift, in this case cosine, that is, cos, and then we would give it the equal. So alpha would be worth 45.5 degrees, which we put here in its place. We already have the alpha angle, so now if we ask ourselves the same questions as before, would we say that we know and what we want to know? Well, it is clear that what we know is, apart from everything that we knew was adjacent to the hypotenuse of alpha, we also know the amplitude of said alpha angle. All of that is what we know we want to find out. Well, opposite side. So it is clear that to find out this opposite leg we can use any of the data we have. For example, the hypotenuse, and what relates the opposite leg to the hypotenuse is the sine function. So we put the function this sine out here and we would say sine of, in this case, 45.57 degrees equal to opposite leg, which we do not know, among 30, which is the hypotenuse. Solving for the 30 that is here, multiplying would happen by dividing, and then the opposite leg would be 30 times 0.71, which is what gives us that approximately. Rounding to the hundredths and doing this operation, the opposite leg is 21.3 centimeters, and that is already, we can put it there in its place. Well, to finish this exercise we only need to find out the amplitude of beta, and since we know that alpha and beta add up to 90, since as before we solved for beta, beta would be 90 minus alpha, that is, 90 minus 45.57. Doing that beta operation has an amplitude of 44.43 degrees. We put it in place and now it is finished. I hope this tutorial has been helpful to you. It would really make me very happy if it did. Just remind you that you have to subscribe and hit the bell so you don't miss any news from my channel.